to embed digital transformation elements with reference to their impact on 5 specific labor markets into curricular education. Today, we are going to analyze, to study how digital tools can also support university and career services to do their job, to reach their objective. Before to go on, I would just introduce yourself, Alessandro, who is the speaker of today's webinar. Alessandro is a consultant for the career service at the University of Padova. As he's going to explain you, he helped us to develop a very useful tool for our career service. So I just give the floor to Alessandro and enjoy the meeting.
Thank you, Sara. Thank you very much. Thank you all. As said, my name is Alessandro Vaccarino. I work for Burning Glass Europe, a company focused on labor market analysis using big data, so using knowledge of vacancies. Today, I'll present you how we can use labor market intelligence, so how we can use knowledge of vacancies to support citizens, corporates, governments, and of course, universities in their work, in their placement work, but also in their course review activities. My intervention will be focused after a brief context of a goal of a system. We'll focus on the methodological approach that we follow. So how we work, how we collect, classify, and how we use those data to prepare information to be shown. So how we can trust those data that we can produce. And then I will present you several use cases of projects that we made in the last years on Italy, on the whole Europe, and of course on the University of Padua. So let's start with the context and goals. The context, of course, is labor market. Labor market that is evolving. You know really better than me. Labor market is evolving due to digitalization of profession, relevance of soft skills, internationalization, new profession and skill emerging, and so on. Of course, also the COVID impact was really interesting to be analyzed because it was a really game changer, sorry, in the labor market. Think about smarter labor working, but also on the kind of contracts offered and the situation that we all are living. We need something to analyze, monitor and analyze how labor market is evolving to help us having better decision, making better decision on labor market and better initiative to support professions in finding and keeping the best work they can have. What we currently have? We have, of course, official statistics. We have a lot of them on all the countries. They are really representative and strong in terms of value, of course. But the main improvement areas are regarding speediness. So those data are not fast because we have to collect them, to structure them, and to analyze them. So official statistics cannot be so fast due to their own nature. And so we will need something to help us analyzing what's happening now. So what's happening, for instance, during the COVID-19 pandemic. And we could also need some more granular data. Some official statistics cannot be so granular due to their own structure. If we have to describe labor market, we use a standard nomenclature that could not fit how labor market is evolving now. So could not fit market terms, emerging skill that does not exist, for instance, 1 year ago or 3 years ago. And so we need something that could be faster and more granular. And that's the base behind web labor market. Because why? Because we can use knowledge of vacancies to describe labor market. Knowledge of vacancies are published by companies. So by their own nature, they must be fast because the company is looking now for professionals. So they are in real time regarding to the labor market demand. They are, of course, granular because a company is engaged to write the best knowledge of vacancy possible in terms of skills needed, kind of contract offered, and so on. Because if they write the best advertisement possible, they will fit the best candidates available. So let's think about using those data to analyze how labor market is evolving. That's our goal. Our goal is to transform what you can see on the left of our screen, so web pages, online job advertisements, in insights. Insights describing us how labor market is evolving in terms of number of vacancies, in terms of geographic, in terms of industries, corporate, and skills, of course. We will see how we do it and what we can produce in the following part of the session. So let's start with the methodological approach. We follow a strong methodological approach based on the KDD, Knowledge Discovery Database, published by Fayyad in 1997. This framework describes how we can transform data to knowledge, passing through a strong methodological pipeline that collects data, pre-process it to ensure quality, transform it to extract information, and create analytical patterns that can be analyzed by an expert to extract knowledge. We took this methodology and we applied it to online labor market, creating what we called KDD for LMI, so Knowledge Discovery Database for Labor Market Intelligence. This framework is composed by 5 main steps. The first one, data ingestion, is focused on collecting data. We are talking about online job vacancies, so web pages. We have to collect them. We have more or less to download those pages. Then we have to process them. First of all, we have to pre-process them to ensure that data we are collecting is in quality. We will talk about it. We have a lot of noise because we are talking about web data. We have to clean it very much to ensure a proper quality on our data. Then we have to extract information. Of course, we're talking about, again, web pages. In a web page, the company will describe the profession as best possible, but using their own language, using their own terms. So we're talking about human kind of expression, human terms. We have to try to extract those terms and to link them to a standard taxonomy, so to classify them, to extract information, make it uniform across knowledge of vacancies, and extract this information that can be so analyzed by labor market experts or decision makers and so on. Then, once we have transformed this bunch of web pages to a structured table, to a structured database, we can create a presentation area and then show our insights, show our KPIs, and so on. But let's start with the first step, data ingestion. Data ingestion, what is? Is the process of obtaining and importing data from web portals and storing them in a database. So download them. We have here to focus on volume. We are talking about thousands or millions of web pages. We have, of course, to maximize the coverage because, you know, we have in a single country several web portals that publish vacancies. How much of them and which portals we have to focus on to describe the most representing knowledge of vacancies on the web. And we have to find a balance between the quality of the data collected and the effort to extract them. Of course, we are talking about real-time analysis. So we are talking about a system that have to collect data really fast, because if I don't collect the knowledge of vacancy today, tomorrow it could disappear because the company could close it. So I have to extract it as fast as possible, but at the same time, I have to ensure a proper quality of what I'm collecting. And so the goals of the system is to build a layer, an ingestion layer that is robust, so robustness of project, that can ensure quality of data collected, and can also ensure scalability and governance of a system, because we are talking of a system that currently is extracting, only talking about European labor market. We're talking about more or less 1 million of web pages collected every 2 days. So 500,000 every night, more or less. So the system needed to be scalable to fit the stationality of the strengths or to scale new countries and so on. What are the issues that we have to address talking about robustness? Potential technical problems when gathering data from a source. We are talking about websites. So specific websites could not be available on a specific day due to technical issues. They could block us to a high volume of accesses on the website and so on. And this could be a risk in terms of loss of data. Because as said, if I cannot connect today on a specific web portal, tomorrow this web portal could contain less knowledge of vacancies because some of them could be closed. And the solution here is to ensure redundancy. So, you know, a specific company, to increase visibility of a knowledge of vacancy, publish it often on several portals. So if we can collect the same vacancy published on several portals, if one of those portals broke down, we could have the same vacancy extracted from another portal. So we have to increase redundancy of those data. Talking about quality, we need to obtain data as clean as possible, detecting structured data when available. What I'm talking about when I say structured data, when you see a knowledge of vacancy on a website, you see a page with a description that describes the vacancy, the company, and so on, and some fields. So for instance, on the right, a rectangular field specifying the salary offered or the place of work and so on. Those data are well defined, are structured because they are positioned in a specific part of the page and they're describing exactly location, sector, contract, and so on. So if we can detect these specific fields, we can increase the quality of the data collected because we will have to focus on description only to extract specific skills and so on. But we can start from an already semi-structured way to read a knowledge of vacancy. So to ensure a proper quality, we have to develop a tailored ingestion. We have to find agreements with web portals when available that can send us data already structured. This is API, Access Point Interface. We made in the years several agreements with portals, and so they can send us every night structured data regarding knowledge of vacancies published in the previous day. When an agreement is not possible due to effort to establish it, due to the fact that a single web portal is not reachable in terms of emails, we cannot contact no one within the company, or the company is not interested in signing an agreement with us, we can use technical approaches, scraping and crawling. Both of them are aimed to extract fastly what we are seeing on a web. So let's think about it as a software, as a piece of code that take what you're seeing on your screen, so you can visit a website, you can see a knowledge of vacancy, and you can save it, you can print it on a paper. Okay, scraping and crawling make the same work, but we are using automatic software. So I don't need by myself to open web page, to click on all vacancy and store them. We don't have a best approach possible. Some of you could think about APIs, so agreements with portals, that could be a really high quality and high performance way to extract data. But we have some issues, we could have some issues finding the right agreement with the company, and we could not have the proper depth in terms of content, because some of those portals could share with us just structure field, but we could also need the description of a vacancy, because you know in the description the company specifies the skills, it specifies the core of what it's looking for. So we have to find the right balance between scraping, crawling, and API for each web portal we ingest data from. And talking about Europe, we are talking more or less to 500 web portals. Then, once done, once find the best way to ensure quality and performance on ingesting data, we have essayed to ensure scalability and governance of the system, because we have to handle a real and complex big data environment, simultaneously connected to thousands of websites. So we are talking to a really big, huge system that have to work 24 hours a day, every day. Because as said, we cannot permit to lose data, because if I lose vacancies, I will lose information. So we developed in the years a scalable infrastructure, monitoring that with custom tools that can ensure us collecting all data available. We are using it since 10 years, more or less. Of course, we are evolving it continuously, but it's helping us collecting data for Italy, and then starting in 2017 for the whole Europe. So just to recap, what do we have now? We have collected data. So after the ingestion phase, we have collected web pages. We are not sure they are proper knowledge of advertisements, but we are quite confident. But those pages are noisy, are duplicated, as I said before, and are structured. So what we need to do is to put those data in quality. And this is the goal of data pre-processing step. Data pre-processing is the process of cleaning ingested data and deduplicated knowledge of vacancies to guarantee that analytical phase will work on data at the highest quality possible. So the main goal of data pre-processing is quality. On the other hand, the main goal of ingestion phase was volume. We have to collect vacancies, advertisements. So how it works? We have, first of all, to detect the language of a page. You know, we are talking about knowledge of vacancies published in all the countries of Europe. So we are talking about more than 30 languages used. And each language has its typical keywords, stop words, and terms used to describe the profession. So we have, first of all, to detect the right language of a system. How we do it? With a machine learning approach, so artificial intelligence, a system trained on Wikipedia corpus that read the vacancy and say, okay, this vacancy is written in Italian, or in Spanish, English, and so on. This is really fast because it has to work in real time, and it has also to ensure a proper performance. So it have to classify well knowledge of vacancies, because we need to know exactly in which language this vacancy is written. Then once detected the language, we have to remove noise. As said, we are talking about web. So we're talking about web pages. We are talking about a lot of noise, because on a web page, I can publish my vacancy, of course, but I could also publish a banner, an advertisement. I could publish a blog page on my website. My website could contain some privacy policy pages, and so on. We have to detect noise and remove it. How to do it? We use some artificial intelligence models quite similar to what you have on your email, the spam filters. So those models was trained to thousands of web pages and vacancies, and they can read a page and say, okay, I'm quite confident that this page is really related to a knowledge of vacancy. Or on the other hand, no, this page is not related to a knowledge of vacancies because it's not using the proper labor market terms, or it's using it, but it's not a real knowledge of vacancy. We find several examples of company that was publishing consulting services instead of vacancies on web portals. So, are you looking for a software programmer? Don't worry. I am a company, I can offer you consulting services. Okay, it's interesting, it's intriguing, but it's not in the scope of our current system. So our noise detection system have to deal with it and then to say, okay, this is a fake vacancy. So I will put it apart and I will remove it from the analytical layer. Then a really big challenge in our work is deduplication. Let's think about, say, a company that publish the same advertisements on 4 web portals because it wants to increase visibility. It's okay, it's part of a real world. But if we can ingest, if we can collect the same advertisements 4 times and we publish it in our analytical layer to our stakeholders 4 times, this data would affect analytics. So I will describe a not real labor market scenario. So we have to detect vacancies duplicated, so vacancy, the same vacancy posted on several websites, and to remove duplicated. So to merge them and reduce them only to 1 advertisement. How we do it? We do it with a mixture of artificial intelligence approaches and statistical-based approach to identify what's the standard duration of the knowledge of vacancy. Because if I find 2 very similar vacancies, but published on within 6 months, one to another, so one published on January 2020, and the second really similar vacancy, but published after 6 months, maybe those vacancies are related to 2 different professions. But if I find the same vacancy posted twice within a week, I can be quite confident that it could be related to only 1 profession looked by the company. So we define the statistical-based approach, more or less an interquartile range, some statistical stuff, to describe what's the standard duration of a vacancy based on the profession and of the province. Because, of course, the same profession could be found in an easier way in a region of, for instance, of Spain, but could be harder to be found on another region of French. So we have to find a standard duration based on the specific geographical region and of course on the specific profession, because maybe finding a software developer is easier than finding other professions, something like project managers and so on. So what we obtain after this phase are unique online job vacancies. So now we are confident that we can ensure coherent analysis. It's now time to classify data. And that's the goal of data classification or information extraction phase. This goal is to extract and structure information from data with respect to the most proper taxonomy. What you use it? We use artificial intelligence, of course. We use taxonomy, I will describe them later, and we use information linkage. But let's start with an example. What you're seeing it is a real online job advertisements collected by our system. In this advertisement, we can say that, okay, there is a company looking for a junior software developer, a description of what we are looking for. We're looking for a passionate, committed developer, able to solve particular complex problems, and the position is based in their office in Harwell, UK. Okay, I could find several similar vacancies to this one, but maybe the title could be quite different. So a junior developer or Java developer, software programmer, and so on. We are talking about human interaction. So everyone can use the terminology they prefer. What we have to do is to take this terminology and to link them to a standard taxonomy, because analysts cannot use an unbounded way to describe a single profession. We have to reduce it to a single term. In this case, software developer, occupational code 2512. Okay, so if we can structure, in this case, the profession to a specific code, but also skills requested, and also the place of a work, we can ensure harmonized, homogeneous analysis to our stakeholders. So first of all, we have to find the right taxonomy. Right taxonomy is used, as said, to formalize all our information, to make it consistent and enable analysis. We have to standardize occupation, skill, places, contract, and so on. And we have to find a unique taxonomy also to ensure analytics across several countries, because you know, each country can describe a profession with its own terms and even its own language. We have to ensure that analysis can be done across several countries. How to do it? Finding the best, most proper taxonomy, if possible, international taxonomy to be adopted. Currently, we are adopting a dozen of taxonomies. The most relevant are ISCO, ESCO from European Union to describe occupation. We are talking about a taxonomy that map all the occupation available in 436 different terms. So it's a good taxonomy. We are talking about ESCO even for skills, and this is a really huge taxonomy describing very well skills required. We are using NUTS and ISO to classify places down to a specific municipality. We use ISHED to describe educational level, NACE to describe sectors, and some custom taxonomies to describe other features such as seniority, working hours, contract type, salary, and so on. So now that we have defined the proper taxonomy to be adopted, we can classify data with a pipeline based, of course, on the language detection and the pre-processing described above, that analyze an ontology-based model based on the specific ontology or taxonomy identified, and develop on top of this taxonomy a machine learning model. So we are talking about artificial intelligence that read, instead of me or my colleagues, reads an advertisement, reads the title, for instance, and say, okay, I can find a junior Java developer. Okay, me as an artificial intelligence process, I can say that those terms, this title, is related to the software developer described before. So what we have now is a standard database. We have a structured database, so an informational base that can be used to enable analytics. Why? Because currently, at the end of this phase, we have structured data where every online job vacancy collected across Europe is standardized, is derived to a unique online job vacancy, so it's deduplicated, and is structured. So we will have several columns describing those vacancies using taxonomies that are, we can say, language independent. So the same position, so software developer, will be classified with the same term, so 2512, the term described before, the ESCO term, without dependencies of a language. So the same code will be used to classify an Ukrainian knowledge of vacancy, an English knowledge of vacancy, an Italian one, and so on. So this can enable us analyzing data across Europe and languages. So the final pipeline of a process is this one. Source ranking, so define the best sources we can use in a specific country to extract job vacancies, validating them using a country expert, and then define the most proper taxonomy and machine learning model. In the meanwhile, collecting data and processing them, and then validating them and release. Once this workflow is completed, we can ensure that for a specific country, we can produce available and reliable information. That said, I've presented you how the system is working. I understand that it's quite hard to understand the whole picture. It's not easy, a lot of terms, a lot of technical stuffs, and so on. And so now it's time for some use cases. I will present you some use cases based on our experience. And the first one is our standard product. That's called WOLLYEDU. WOLLYEDU is a portal where we collected, starting in 2013, if I remember well, knowledge of vacancies published in Italy. So we're talking more or less about 7 million knowledge of vacancies collected, put in quality, and then classified and exposed through information. I'll show you live. If you want, you can go to wollyed.com and navigate those data. The second section, this one, is open to public. The first one is under registration. But let's see what we mean with labor market intelligence. Let's start, for instance, with the area example. Okay, as said, I have to log in here. Okay. Area dashboard is presenting me, of course, Italy, because you are talking on the Italian labor market. I can select on which area I'm interested in. For instance, I will select the province of Padua. Then I can select the occupational group, so in which kind of occupations I'm interested in. So for instance, clerical support workers, elementary occupation, managers, professional, service and sales worker, and so on. I'll focus on professionals. And then the system will ask me on which temporary period I'm interested in. We want to analyze the labor market across the last month, the last quarter, the last semester, or the whole year. Okay, I'll focus on the whole year. Okay, what the system is giving me? The system is giving me the list of professions with respect to the ESCO taxonomy presented above, with the number of vacancies published in the analyzed period, so in the last year, the percentage of permanent contracts, and the information regarding if occupation is can be analyzed as cross industries or no. I'll focus, for instance, on the most requested occupation in this province, software developers. Okay, let me talk about software developers. What the system is giving me is an identity card of this profession in the specific geographical area analyzed. So what we're seeing it is the number of vacancies published during the last year for software developers within the province of Padua, the rate of permanent contracts, and the rate of experience over 2 years. So the rate of vacancies that are addressing people with at least 1 or 2 years of experience, so not graduated. We can go deeper here. We can analyze the distribution across experience. I want to repeat, experience as explicitly specified by companies in knowledge of vacancies. So what you are showing here is what you heard from the noise of the web. So within vacancies, we found 51%, so half of the vacancies was asking for new graduates, so young people, junior profiles, and so on. Then 20% more or less are looking for professional with an experience between 1 to 2 years, and so on. We can also analyze, for instance, contract typologies. So which kind of contract I can expect as a professional within this area. We're talking about 54% of temporary contracts. That's higher compared to the whole occupational group. So in this case, software developers has a higher rate of temporary contracts compared to the whole occupational group of professionals that I selected during my query on Wally. I can also analyze the most demanding sectors within the province for this profession. The first one is computer programming. We can talk about it as a consulting sector. The second one is manufacturing with 60%, and so on. And we can even analyze the most requested skills. So what are the most distinguishing skills as specified within the knowledge of vacancies? So what are companies looking by software developers now. We will come back on it later when we will talk about the project started with the University of Padua. As said, we adopted taxonomies. In this case, software developers as a code 2512 already said it. If I click it, the system will bring me to the page of ESCO project. It's a project by the European Commission that describes how the European Commission is looking at this specific occupation. So what this occupation, what are the main goals, and so on. So this is the first entry point of our system. As you said before, here we have 4 entry points. So we started from geographical analysis. We can, of course, start from skills, from industry, from occupation, to reach the identity card. So for instance, I want to understand what I can do with my skills. I start from this, I say, okay, I'm good in communication techniques, I'm good in office software, and I'm also good in quality standards. What's the best profession that fits my skills? Here we can find that accountants has 28,000 of alleged vacancies published in the last year and have a good fitting point with my skills. So, okay. What's the labor market demanded for this kind of profession in Italy in the last year? Here it is. So what you are seeing is the same identity card shown before. And this is this kind of mix, so experience, content topologies, subsectors, and skills. I can reach the same kind of identity card starting from industries. So I want to work in a specific industry. What's the kind of skills that I need, the kind of profession that I can do, and so on. And the same starting from occupation. So I want to focus how labor market is evolving the whole country, a specific region, for a specific occupation. The system will bring me to the same identity card. I saw that there are a lot of friends from Spain here connected. So I just wanted to cite that we made exactly the same project with 2 Spanish regions. The first one is the Basque region with the bizkayatalent.eus portal. You can reach this portal, is open to public. You can find the Observatorio Vasco de Talento. Sorry for my speech, I'm not a Spanish talker. And what you can see here are the same kind of dashboards. So analyst, we have area, skills, industry, and occupation dashboards. Exactly what we said before, looking at the WOLLYEDU. And we have also the 4 open dashboards. You can reach them, open them when you want without registration. And the system will show you the number of vacancies published, new vacancies published by week, or the active vacancies by week. So the number of open vacancies, the most demanded occupation within the region, and the geographical distribution. You can see the same also looking at the other open dashboard and so on. So what the system is giving you here is the same we saw for WOLLYEDU, but focused on Basque region. We are releasing it, we will release it, I think, I hope, in the next month, even for Catalonia region. We are proceeding in a portal with ACU. Maybe I have something preliminary that I can show you. This is the same web portal I showed you for Bizkaia and for WOLLYEDU. You can access the same dashboards that are focused on Catalonia region. So we are defining this project for several, we have other regions across the Europe, in Germany, in French, and so on. So the goal for this kind of system is to bring labor market decision maker and citizen a transparent view and complete view on how labor market is evolving on a specific region or country. This is not the only project that we can do using our data. We also developed a project for the CEDEFOP, so for the European Union, to analyze labor market across the whole Europe. We released it. You can see those kind of data looking at the Skill of 8 project that CEDEFOP released. Those are open dashboard that you can use to analyze, for instance, how skills are evolving for specific occupations. So we can change, we can analyze the most requested skills for a specific occupation. And of course, this kind of analysis can be time dependent. So I can make the same analysis focusing on 2017, 2018, 2019, 2020. So how professions are evolving in terms of skill set across years. It's a really powerful project where we are continuing to develop with them. And you can reach it Googling for Skill of 8 project. And the last one project that I want to present to you because it's really, really interesting is WOLLYEDU. What is WOLLYEDU? WOLLYEDU is another interface for the same data that we already classified, but focused on universities and the training providers. What's the goal? The goal is to say, okay, can we use this kind of data to support universities in placement and course reviews? We said, okay, maybe we can find something. We can find a way to expose those kind of data to universities. We started a pilot project with the University of Padua last year, if I remember well, analyzing the official document that the university has to compile for each course degree. In Italian, we can call it schede sua. They are official documents that where lecturers have to describe the course degree, so how it's structured, the number of hours, if there are labs, and so on. And there is a section where lecturers can even specify to which kind of profession this course degree is aimed. So which kind of profession we can prepare. In terms of, even in this case, human terms, so it's not a flag on some terms, on some taxonomies, but is human interaction. I will write my own description as a lecturer, so as a person that knows very well the context of his course degree, describe to which kind of occupation this degree is looking for, is aimed to. So we used this kind of data to extract data coming from our system. So, okay, if your course degree is aimed to prepare software developers or sales manager or statistician on lawyers and so on, what we can say you about labor market related to that specific professions. And this kind of analysis can give really valuable insights on how you can support students finding the right job for their profession, but even how you can support lecturers in reviewing their courses. I show you live. Here it is. Just refresh the page. Okay, so how the system is working. We can select one of the course degrees offered by University of Padua. Those are a subset of 15 courses, 20 courses that we selected for a pilot project. In this case, for instance, I can specify data science or whatever I want. And the system will give me, okay, what's the trend of online job vacancies directly aimed to find professions related to your course degree. So we're talking more or less to 1,600 vacancies published in 2019 in this case. Okay, but which kind of professions companies are looking for? We can say it. We can. This chart is saying me that the most required occupation with the 600 vacancies published last year are related to machine learning engineers, followed by data scientists, followed by artificial intelligence developer, and so on. We have also some vacancies related to NLP, so natural language processing experts, big data architect, and so on. So what we can find here is what the market is looking for in Italy for occupation that can be in some way related to the specific course I'm offering. So what we are not seeing here are developers, because this course is not aimed to train developers. For this kind of profession, we have computer science degrees and so on. This course is aimed to train machine learning engineers, machine learning developers, artificial intelligence developers, and so on. But which kind of companies are looking for those professions? So there are big companies, small companies, or whatever. What we have it is a representation of the top requiring companies as they are specified within the knowledge of vacancies. So we can find some top companies, followed by tons of small companies publishing 1, 2, or 3 vacancies. But which kind of contract we can expect, and are those companies looking for young, junior, or senior professions? We can see it here. So here you can find the experience required, so no experience, up to 1 year, from 1 to 2 years. The same we saw in WOLLYEDU, but in this case applied to that specific scenario, and the kind of contract offered, so 36% of full-time contract. And I want you to show just a last slide that's related to competencies. In this case, what you're seeing are competencies, the balance of competencies related to a specific market term, so to a specific occupation. In this case, if the bar presented within the slide is moved to the left, so for the specific occupation, there are most technical specialists, hard skill required. On the other end, for instance, for artificial intelligence developer, there are mainly digital skills required. In this case, for instance, we are seeing that deep learning engineer has a big relevance rate of technical specialist skills. Okay, but why? Why it's so different, for instance, compared to an artificial intelligence developer? What are companies looking for? Okay, we can click on it, and the system will give me the top required skills. The top required, in this case, technical, hard skills required by the companies. And here what we can say, it's Italian, but what we can say is that companies are looking for deep learning engineers with the knowledge of mechanics, of energy, sectoral, for energetic sector, electronic components, building components, and so on. So here a deep learning engineer need to know something about building engineering or electronical and mechanical engineering, and so on. On the other end, an artificial intelligence developer have to know cloud technologies, computer security, machine learning models, and so on. Okay, so what we are seeing here is that for a specific occupation, the requirement in terms of skills can be very, very different. And this kind of slides is supporting lecturers in defining, redefining, and finalizing their course degree. So for instance, inserting some specific courses related to building engineering and something similar for specific deep learning engineer students. And on the other hand, inserting some more technical courses related to artificial intelligence models to people that want to become an artificial intelligence developer. So that's the goal of this system, WOLLYEDU. Thank you very much for your attention.
Thanks to you, Alessandro, for your detailed description of this very interesting and powerful tool. I decided to show you this tool because I suppose that there are a lot of connection, especially with the DEDUPLICATION project, for studying and have a deeper knowledge of the competencies needed in each field that we want to study during the project. So the presentation of Alessandro was really interesting, but to mind it was really technical. So maybe I suppose maybe you can have some question to ask. You can choose to turn on your micro, or maybe you can write your question in the chat. Yes, if you want to have the presentation, Julia, you can write me. I write you my email address, and then I can send you the full presentation. Also, I remember this webinar was recorded, so if you want to have the recorded version of the webinar, just ask me and I can send you the link. No question? So Alessandro, you were so clear.
Whoa, I didn't expect it. Great.
We hear you very low, Diana.
I'm trying to put the mic closer to my mouth. So hi.
Hi, Diana.
I have a question for Alessandro.
Yeah.
We've seen that WOLLYEDU is for Italy. It's for the labor market in Italy. Is it possible to develop or to have a broader image and to add other countries? You mentioned about Catalonia.
Yeah, we developed the same system, a copy of the same system for countries, for instance, for
Yes.
French, but even for region. Yeah, so it's possible because currently we are covering labor market within the whole Europe and also on Northern African countries and Eastern Europe countries. So,
okay,
yes,
we are interested for Romania.
Yeah.
Because it looks great.
Yeah, we are working with ATF on your countries, or even with Ukraine and so on. But if you want, we can keep in touch to discuss about it.
Yes, we would like to. Great. Thank you. And is it possible to make an account from Romania, let's say, because I've seen that there is a login button there, but
yeah, if you want, you can write me. I'm writing my email in the chat just to enable you a demo account.
Okay, thank you. Thank you very much.
Too.
Do you have a question, Paulina?
Yes, I have. Actually, I have like two questions to Alessandro. Thank you for very interesting presentation about the methodology of analyzing online vacancies. I'm under the impression, because actually I am dealing with this problem in our career service at the Jagiellonian University. Actually, we introduced this kind of system based on Power BI. Power BI tools and other services of Microsoft for analyzing. And I have two questions, because as I understood, if I don't, please correct me, you have chosen some portals with job vacancies. And this tool, this methodology and this tool you presented us is devoted for university, as I understood. So how do you did you deal with solving the problem that with choosing the proper vacancies? I mean, not every online job vacancy is dedicated for a graduate of university. So you know what I mean, because when we are dealing with this problem now, and we decided to analyze only these vacancies which are published on our website, because we have no sure. Yes, so it is my first question.
Okay, thank you. Yeah, in this case, it is true. The last portal we saw, so WOLLYEDU, was explicitly developed for universities. In this case, we selected, we can select two kinds of data. The first one is related to which professions. And in this case, the linkage is made by syntactical language of the document presenting the degree. So we took those documents coming from the colleagues of University of Padua. We passed them through an artificial intelligence system to extract information. So the system more or less read the document and say, okay, this degree is preparing for those occupations. So extract more or less from 10 to 25 occupations for each degree. And so we used those professions to filter our data.
Okay, so the name of the occupation was a key, yes?
The first one is the name of occupation, yeah, in terms of market terms. So we are not using only the taxonomy, so the ESCO terms, because in the case, for instance, of data science presented, all data scientists, software developers, software analysts are all behind one specific term. So in this case, it will not granular as needed. So in this case, we developed another level of granularity, and we used professions to filter. We didn't filter the system by experience, so exposing only occupations, only vacancies aimed to find young people or junior professions, just because we can expose, we exposed, of course, the level of experience required, but giving a view on the whole sector, so for all the experience levels, we can ensure that the university can also take a look on what could be the expectation in terms of finding a job for senior professions. So, okay, I can find an occupation right now, but within 5 years, 7 years, will be my kind of profession required, or senior occupations are not required in Italy.
Okay, thank you. So can I ask the second question only?
Yeah.
Okay, so as I understood, we now have the set of job online vacancies devoted for graduates of the university because of the name of the profession. And now the problem with which I am dealing with is this classification of competences and skills. How do you deal? I know that you said something about taxonomy and classifications. However, was it possible to use this artificial intelligence to take every competence, because sometimes in online maybe in other words, online job vacancies are written in so many different ways, especially competences, that sometimes one skills is written like in 20 different ways, so it was also solved by artificial intelligence, yes?
Yeah, the goal of artificial intelligence is to detect, despite of a type of terminology used, to detect the proper skill. Regarding this, please keep in mind that talking about the ESCO taxonomy, we are talking about a taxonomy containing more or less 12,000 different skills. And for each skill, our system derived more or less for each skill 25, 35 different ways to specify them in knowledge of vacancies. So we have a system that can detect, I think, most of all the ways to specify skills.
And my last question, I promise, is how many, because I'm really curious about it, how many IT specialists and developers are working in this project? So how many people were engaged to do this,
system.
you know, this, yeah, to work on this result you presented, because we are dealing with this problem also.
Okay,
Okay, thank you.
Oh, you're welcome. Currently, talking about, I'm counting the desk in the office. Currently, we are two colleagues aimed to the ingestion phase, and 2 people that developed, me and the colleague that developed the artificial intelligence layer. Then we engaged a provider to help us defining the web interface. But we are talking about an average of 5 people working on it. We are all people coming from the University of Milano Bicocca, so all we can say expert in this kind of methodologies and frameworks.
Thank you. Congratulations.
Thank you very much. You're welcome.
No more question. Alessandro is here available for you. Okay, no. Alessandro also wrote his email in the chat, so if you have more questions for him, just contact him or write to me. You have also my email. You can also write me. I remind you to have the presentation and the recorded the link to the recording version of this webinar. So I was really happy to have you with us today. If there are no more questions, I would just thank you and wish you a nice day and Merry Christmas. Maybe we are just close to Christmas holiday. So maybe we can just turn on our camera. So maybe we can say goodbye each other if you want.
Goodbye, everybody. Thank you.
Oh, nice to see you. Okay, have a nice day to all of you, and thanks for joining. Bye-bye.
Thank you all. Bye.
Thank you.